Good morning, everybody. Today is Tuesday, September 1st, 2020. And what I'd like to do today is a little code demo. So, as you may have seen on the blog, I am bartering some of my developer time with a friend. And so I'm working a little bit on his side project, and he's working a little bit on my side project. And for his side project specifically, he is building a iPad application. It'll be a document-based application. It's a drawing app of a certain kind. And so he was interested in thinking about the file type of these documents. And there were some general questions about how, just document-based applications work and how that's been changing with some of the new additions to Swift UI. But then more specifically, we're kind of interested in looking into the problem of the file type and its schema. And so this is the basic idea where you start working on a project and you are saving to a file, and then over time you are making adjustments to the file type because you are adding new attributes to your core objects. You're deleting core objects and creating new ones, and so forth and so on. And so, I mean, first off the bat, we kind of built some assumptions, right? So I'm going to open up the README file. So this is a project I called versioned files demo, and in it, it'll basically demonstrate an approach to handling this. And so, just off the top, we'll talk about some of the required behaviors. So this is going to be a document-based application. We're going to assume that we are going to be saving a flat file, and the content is going to be printed JSON. And one of the reasons we're doing this is just for simplicity. When you are building a document-based application, you use file wrappers, which you can create a file wrapper, which is more of a package, where basically a folder is created, and then you can put resources in that folder. And then from a user perspective, it's kind of like visualized in Macintosh and iOS as like a single document. A lot of documents use that. There are a couple things you need to be aware of with regarding to like how Dropbox and a couple other file management systems handle those. But anyway, that's off the table. We're going to focus on this is a document-based app. It's going to save a file format that's in JSON, and we'll do that in a flat file, so it's a little bit more simple. Yeah. And so the one of the big behaviors that we want to verify is this idea that we want to let the user start to use the app. And so the idea is they're going to start generating these documents. And as we make changes to the schema, we want there to be a clear migration path so that when they open up a document that was saved with a version 1 of the app, and we're now version 3, it can actually do that. A couple other assumptions. When we're migrating the file formats, the idea is we are going to chain them so that if the system is handed a version 1 schema, it'll translate it to a v2, which will then translate it to a v3. We're doing this to keep the code simple. In time, there might be a benefit for jumping from a 1 to a 3, but it's like a nice to have. And we're just going to keep it kind of chained for now. The other kind of assumption here is that during a migration, you will need to transfer some data one-to-one, meaning like it just stays in place. Some data will need to be transformed. Some data will need to be outright deleted. And then some new data may be optional, and some new data may have requirements where you have to provide a default value. So we'll kind of demonstrate all that in all of the migrations that we build. We should have test infrastructure to validate that it all works. And yeah, I mean, that's about it. You can read up this on your own. I'll have a GitHub link in the links below. But yeah, so let's just kind of give you a little tour of what this looks like. So first we'll talk about the core data model. And so this is a simple app. I'm actually not even going to demo the UI. It's basically you launch it. It's a list, and you can generate just random people. You can do that on your own. But basically, the idea is that the app will launch with this person model, which at this moment just contains a ID and a name, and then over time it'll evolve. So in version 2, we added, or I'm sorry, we added first name and last name, which are basically, we're kind of transforming the name into 2 separate elements. And then in the current version, which is version 3, we've added some more. So we've added birthday, which is an optional date, and we've added mark as favorite, which is a required bool. You'll notice off the thing here, I don't know if I can show this. Yeah, I can. You'll see here in the Xcode, the person.swift is part of the targets. Person dash v2 and dash v1 are not part of the targets. These are here for reference only. And we'll talk a little bit more about some of the decision making behind that later. But person.swift is the only thing that's actually compiled and included in the target. These are just here for reference. But that's basically how we got here. And so this is a document-based Swift UI application. And so we have people document, which is implementing the file document protocol. This requires an initializer and a writer, basically. And it also requires this readable content types collection, which is something that we've defined ourselves. The big thing here is to know that a people document has a collection of people, which is an array of person types. And this is what it uses as its central storage system. Now, the interesting stuff comes with file. So people document is here, and it has its own set of responsibilities. And so the first big decision I made was I want to create a new type to kind of own the responsibility for migrating the data. And so what I did was I created a type called people document file representation. And so the idea here is that this is a type that will own the idea of basically serializing and unserializing the content. And then if a migration is needed, it is the object or type that will control that. So we've got people document file representation. It's got some published versions of errors that can happen during migration. And the general idea is that you will initialize it with a big chunk of data, and it will attempt to decode itself into its file representation type. And then if that fails, it will attempt to do the migration. So the idea here is that we're going to make an assumption that like the system is built for version 3 and it's opening version 3 all the time. But then if it can't open a version 3, then it'll attempt to do the migration. And this is kind of an optimization way. So we don't want to have to like sniff each file for their schema version and then make a decision. We're just going to kind of make an assumption for the sake of performance. And so the idea here is that if this fails, it'll try to migrate it. So people document file representation, migrate data. So you pass in some data. It's all abstracted away. How the migrations happen, we'll demo it in a second. So then you're handed the migrated data, and at this moment, you can be a little bit more confident that it's actually at the version 3 that you need. And so you use your decoder and do that there. So, so taking a look at how the migrations work. So one of the big decisions I had to make working on this is how I want the migrations to work. And my initial reaction was to actually use the strongly typed system of Swift to be very explicit about this is a v1 version of person, this is a v2 version of person, and this is a v3 version of person. But the problem I observed as doing that was once you started to attach the version of the ultimate schema to the type, it just kind of polluted the entire code base, because now all of a sudden, instead of creating person, you were creating v3 person or v4 person, and so it added a lot of overhead. So the idea, like one of the goals here, is to minimize overhead from a developer's perspective of like, I'm changing my domain model and I don't want to have to update code everywhere. And so I backed away from that, and then took the idea of, instead of using strong types, we're instead going to use the fact that we're kind of making the assumption that we're building on top of a JSON file, and we are going to let a developer create almost like surgical migration files that define how you migrate a JSON payload from schema 1 to schema 2 to schema 3. And so that's what you kind of see here. So we've got some files that document what a migration from v1 to v2 looks like, and then what a migration from v2 to v3 looks like. And it starts with JSON content. So JSON content is just a kind of generic collection of value types with the assumption that we have string keys, and then we have an optional any type for its actual value. When the file representation starts its migration, it's handed a chunk of data. And so what we use is the older JSON serialization object to basically just pull that in as just raw values. And then we will kind of hold that, contain that JSON content, and run the migrations over it. So the idea is, so as you migrate from version 1 to version 2, this is handed in the JSON content, and then we iterate over it. So if you noticed, from version 1 to version 2, the big change was we took the name and we introduced first name and last name. And so what we need to do is kind of change that name into kind of two separate value elements, as well as update the schema number. So if you look at the people document file representation, you'll see not only does it hold the people, but it actually has a property for schema version, which basically just keeps track of this, like, is this schema 1, is this schema 2, or is this schema 3? So coming back to the migrator, you'll see we basically take the JSON content, we create a mutable version of it. We then try to grab the people collection out of it, throwing in an error if that is not available. Then we iterate through the people collection, splitting the name. And we do a little check here to basically say if they only have if they don't have a name, we throw an error. And then we try to take the name and split it amongst a space. And then if they don't have a space, we basically just assume their name is just all shoved into first name. I do have a comment that this is a pretty naive attempt at splitting a name into first name and last name parts, but for the sake of demo, I think it works fine. Cool. So yeah, that's how we handle the name stuff. And then once we have changed the people collection, we update the value in the mutable collection. We also update the schema version to 2. And now at this point, the JSON content can be considered a valid representation of the version 2 schema. And then this will be handed to the migrator v2 to v3. And this is a similar one where we grab the people collection and we iterate over it. This time basically looking, attaching new values for these new properties that were added. So if birthday is an optional, and so we basically give it a value of nil, and update value for Marcus favorite is required value, so we actually have to pick a default. The default for us is false, and so we do that. Then it updates the people collection and updates the mutable content to schema version 3. So yeah, just looking a little bit how this works. Inside of people document file representation, at the top we've got a list of known schema versions, and then the current schema version. So if you were to add a v4, this is kind of where you would start to do that, and then you would create a new migrator from v3 to v4. As far as people document file representation, we do throw an assertion if the schema versions don't match. That's mostly for development and testing. This is not going to be seen in production because assertion failures are pulled out in most production release builds. And for the migrator, you kind of saw how we kind of unpack this into JSON content. Then we run the migrate JSON content, which is basically a little recursion that's happening. So you'll see we kind of grab the current schema version, and then depending on the current schema version, we run a migrator. So this is where you would add a version 3 to version 4 migrator if you needed. At this point, version 3 is current, so we just return JSON content, and it can kind of do its thing. This is it's pretty standard. We do keep we do dry up our decoders. So we make a point to create a file representation, a static accessor for decoder and encoder, and just making sure that we add a date encoding strategy, so that way we can actually see the dates in a more human readable expression in the JSON. We also use pretty printed, so that way when the encoder generates the output, it actually looks a little bit nice. Yeah, and so the idea here is that I'll show you what this looks like from file people document. Actually, we'll do it for. So yeah, so as a people document tries to get instantiated by the document-based system in iOS or Macintosh, it'll call this initializer, which is called with configuration, read configuration, and we pull out the file contents from that. If that's not available, we throw an error. And then we instantiate people document file representation data. And you can see inside the initializer for this, we're basically doing the migration if we need to. If not, we'll just return the new decoded file representation. And then once you have the file representation, then you can kind of cherry pick out the content that is appropriate for your document. So in this case, people document needs the collection of people, and so you can just pull that right out of file rep and assign it to your property. For writing stuff out, the system will call file wrapper configuration, and you basically here are charged with returning a file wrapper. And so what we do is we use file representation again. We pass it the people that we want to save, and file rep will basically be able to generate the data that we can put inside of the file wrapper. That's about it for today. I think I'm probably going to do another video to show a little bit about how I tested this, because there's a couple interesting ideas there. But yeah, I think this is a really good demo of how you can approach using a very simple JSON file as your main storage mechanism, either for a document-based app such as this, or for a more shoeboxy, data set that you see in other apps. And yeah, you store everything as JSON. You've got a simple way to kind of migrate it from different file schemas over time. And this is a whole lot less code than core data. Core data is great for when you need it, but if you have a smaller data set that can live in memory at one time, there's definitely benefits to kind of just using JSON for that. And so I think this is a nice little demo. Hopefully you enjoyed the code walkthrough. As I said, this is available on GitHub, so you can check that out. And if you have any questions, you can ask me or post an issue on the project. But other than that, that's it for now. Hopefully you enjoyed this, and we will see you next time. Bye-bye.